Hi, this is an example of using quadratic functions and maximizing uh, the quadratic. So suppose that the manufacturer of a DVD player has found that when the unit price is P dollars, the revenue R in dollars as a function of the price P is this equation. R of P equals negative 3.5 times p squared plus 945p. So what we want to know is what is the price, so we're looking for p, for which the revenue will be maximized. And remember, when we're maximizing quadratic functions, meaning that they have like a square as one of the variables, p squared in this case, we need to find the vertex. And the formula for finding the vertex is usually x, but that's when x is the variable here. And since the variable is p, we're going to write p equals a negative b over 2a. And our b is the number in front of the p, so it's going to be the 945 there. And our a is the number in front of the p squared, so we're going to substitute it in for there. So that gives us a negative 945 over 2 times a negative 3.5. And 2 times the negative 3.5, oh, I typed that wrong. Give me a second, is 7. So it's a negative 7 in the denominator. So we have a negative 945 divided by 7, negative 7, is a positive 135. And that's the price that the revenue's maximized. So that's one of our answers. Remember, P is in dollars. Now we need to find the maximum revenue. Well, to do that, we need to take what we found for P and substitute it in for the P's in the equation. So our revenue at $135, which is P, is a negative 3.5 times 135 squared plus 945 times 135. And then we just solve. We're going to do our square first. That's 135 times 135. So we get negative 3.5 times 18,225. And then we're going to do our multiplication. So negative 3.5 times 18,225 is a negative 63,787.5. And then we add that to 945 times the 135, which is 127,575. So let's add that. And that gives us a positive 63,787.5. But remember, revenue is in dollars, so we write it as in dollars. That is 63,787, and instead of 0.5 we have 0.50, which is 50 cents. And that is our maximum or maximized revenue.